All right, as we start statistics and we're talking about expected or mean value, the mean is the average of what has happened, and the expected value is the average of what is going to happen. And we're going to talk about fair games while we're doing this. A game is said to be fair if the expected value, after considering the cost, is zero. If this value is positive, the game is in your favor or you win. And if the value is negative, then the game is not in your favor and you lose. And what we're going to do is we're going to create a table. The top is the X's or the events, and the bottom is the probability of these events, and they should add up to 1. So the events on the top and the bottom is the probabilities. And to find the exact expected value, we multiply the columns and add. And that gives us the mean value. Okay. If we're using the calculator, we would do stat edit, and we would do L1 and L2, then stat calc number 1. The list would be L1, and the frequency list would be L2. And if there is a cost, we subtract the cost from X bar. So we do X bar minus the cost to get the expected value. Okay. So if we were doing this, we would do 400 times 4/7 plus a negative 800 times 3/7. And so that's how you would do these if you were doing them by hand. You multiply the columns. That's what it means by multiplying the columns. You multiply this times this times this, and then you would add here. And so this value is a negative $114.29. So you would expect to lose this amount if you played this game. Okay? So number 2, it says a $20 bill. So let's talk about what we have here. We have a $20 bill, and it says a $20 bill. That means there's only one. We have 2 $10 bills. We have 3 $5 bills and 4 $1 bills. Okay. Well, how many bills do we have altogether? Because we want to know the probability of getting these. So we have 4, 5, 6, 7, 8, 9, 4, 7, 8, 9, 10. And so the probability of these is this. And so if we wanted to do the multiplication, we could do it by hand. Here's how you would do it in your calculator. So you would go to your lists. So you would do stat edit, clear out your lists. And so you put the 20, 10, 5, and 1. And then you would put in 1/10. And it's going to turn this to a decimal, and that's fine. 2/10, 3/10, and 4/10. Then we would stat, calc, and we want to do a one variable statistics. Even though we have 2 variables in there, we're going to do a one variable statistic. And we put L1 for the list, and we make L2. So L2 is right here. So we do second number 2. And when we calculate that, we're only looking for this number right here. Okay, so 5, 9. And so that is our expected value, $5.90. The X bar is our mean or expected value. Okay. So $5.90 is what you expect to get when you play this game. Okay. So you can also use it when you're trying to decide how much you think you're going to end up paying. So here it says you expect to purchase a toaster. The toaster costs $10. The probability of that toaster is 70%. Well, that's 0.70. And $20 toasters, the probability is 0.20%. And the $50 toasters are 10% or 0.10. So what we should have done, make sure is we have 1 here. So 4 plus 3 is 7. So 4, 7, 8, 9, 10. So 70, 90, and 10. So that's okay. So we could do this one by hand if we wanted to. We could do 10 times 0.70 plus 20 times 0.20 plus 50 times 0.10. And we should get the value to be $16. Okay. So doing this in L1 and L2 or doing it by hand, this is what you would get. Okay. All right. So this one says a game consists of rolling a colored die. Well, dice have 6 sides. So the green has 3 sides, so 3 out of 6. The red has 2 sides, so 2 out of 6. And the blue has 1 side, so 1 out of 6. That's our probability. A roll of red loses. That means you're going to get no dollars for red. A roll of blue pays $6. And a roll of green pays $2. So we want to know what is a fair price to pay to play. So in other words, what would it cost to pay this game? So what's the average price? Okay. So we would say, if we did it by hand, we did it in our calculator. So stat edit. Let's clear out our list. So we have $2, we have $0, we have $6, and we have 3, 6, we have 2, 6, and 1, 6. And if we stat calc this, one variable stats, L1 and L2, we're going to calculate, and our mean value is $2. So the fair value game for this game is $2. So if it costs you $2 to pay, then you would break even. If it costs you more than $2 to play, you would lose. If it costs you less than $2 to play, you would win. Okay? And so that's what you want to think about. So here, let's think about this same problem. So now they're changing the amount of what you win. So green is still 3. Now they're doing red has 3 out of 6. And green is 2 out of 6. And blue is 1 out of 6. Now it costs you, it says a roll of red is $0. A roll of green is $2, and a roll of blue is $5. So since we already have this in our calculator, let's just change our dollar amounts. So we already have the 3626. That's 362616. So now our dollar amounts are 0, 2, and 5. So when we stat calc this, it says that the expected value for this game is, your mean is $1.50. So this is what is expected that you would win. So if it costs you $2 to play, then you're going to subtract that $2 from this. And now your expected outcome is a negative 0.50. Well, that means you lose 50 cents for every game. And you don't want to lose 50 cents. Okay? So you don't want to lose 50 cents. So then I wouldn't play. Not play, right? All right. Last two problems. Jennifer is playing a game at an amusement park. It says she will score 10 for 0.1. She will score 20 for 0.2. She will score 30 for 0.7. What do we expect the number of points to be? Well, we can do this by hand. So 10 times 0.1 plus 20 times 0.2 plus 30 times 0.7 equals, and we should get 26 points. Okay. And the last one here, it says players take turn. We're going to make $100, $300, $400, or $800. Okay. If $100 is 4 nights, and $300 is 2 nights, and $400 is 2 nights. Well, they didn't tell us what the probability of 8 nights is. Well, there's 4, 5, 6, 7, 8. Well, how many nights are left? Well, that makes 1 ninth to make 9 nights, right? So now we can plug that in our calculator. So we get 100, 300, 400, 800. We get 4 nights, 2 nights, 2 nights, and 1 night. And we're going to stack calc this number 1. And so we get $288.89. So that's the expected value of spinning the wheel 1 time. And that's all you would do. Okay?